Yet? Okay. One more time. I'm a PhD student at the Professorship of Forest and Agroforest Systems in Freising. And yeah, I'll maybe take you on a small excursion to the forest where our timber does come from. And my topic is the future potential of forest admixtures of beech with Douglas fir and silver fir. So just a quick background, German forests, as you know, have been affected by drought summers between 2018, 2020, most recently 2022, and this caused, for example, an average decline of growth of 41% in Bavaria. And as already mentioned in the first presentation, spruce was most severely affected, so there was dieback and decline. And beech, which is an important native species, is also climate sensitive and was quite impacted by this. So now the question is, okay, are there alternative tree species that we can use to get ecosystem services and at the same time also meet timber demands? So mixed forests are a solution to maintain our timber demand, but also in a sustainable way, specifically with more drought-adapted species. So usually in forest management, historically it's been monocultures, and now this is being implemented more and more. Mixtures are beneficial for facilitation and complementary effects. So if you have two different trees with different physiological properties, they don't compete as much for the same resources for light or water. They will require different amounts or at different times. Douglas fir is more drought-tolerant species than spruce. There's been studies looking at this. It's non-native and it's adapted to more hotter climates in its native range. And silver fir is a native alternative, but less predictable under future climate scenarios. The drought resistance of mixed forest remains uncertain. There have been studies, many studies done, but some have found positive, some neutral effects, so there's more work to be done. Just a bit more background to Douglas fir. It's kind of a bit controversially discussed as an invasive species because it's not native, but actually it's quite established quite a lot in Europe or in a lot of countries. For example, in Germany, 1 to 5% is covered by Douglas fir. We did a literature review where we found that the effect of Douglas fir on native biodiversity, so for example, birds, arthropods, etc., is mostly non-significant. So 78% was non-significant. But this was only 32 studies, so there's actually a significant knowledge gap on this still, and also these studies didn't look at different management styles and forest types. So you can't really say right now that Douglas fir is just damaging natural forests. Just a bit of background to our project. We are between TimCoM and Göttingen University, and we investigate the admixtures of Douglas fir and silver fir with beech as an alternative, suitable alternative species in managed forests. So two of my colleagues are looking at above ground biodiversity, so birds, arthropods, bats, and my other colleague is looking at soil fauna, and my part is focused on growth and structural metrics of these forests, especially in the context of drought, and the rest of the presentation I will talk about this part. So just quickly to our study area, because we had to do some field work to get our data. We were in Spessart, which is in northwestern Bavaria. It's a large contiguous managed forest where we have many different sites where we have mixed forest with beech with Douglas fir, beech with silver fir, and we also had pure beech plots as a reference to see if beech actually just does better in pure beech plots. And yeah, we did our sampling on each plot on 2 neighboring trees. So always beech with Douglas fir, beech next to silver fir, or 2 beech next to each other on 1 plot. And what we did was, we did a growth increment analysis. So we took tree cores from these respective neighbors, as you can see in the picture, and we get these cores here where we can measure the growth of the trees from 2000 to 2022. So this way we capture a, I don't know if you can say historic drought of 2003 and the most recent ones. Here, Douglas fir, you can see the rings quite easily. It's quite easy to measure. This is actually a good example of beech, so you can imagine what the other bad examples might look like. But yeah, so now I'll just show you some results that I hope to publish soon. So here you can see the results of the growth increment analysis. So on the x-axis here we have the years from 2000 to 2022, and on the y-axis we have the mean basal area increment. So basal area is just the cross-sectional area of the stem at breast height, and the increment annually. So up here we have Douglas fir and silver fir. Down here we have beech. And just what you can see first is that Douglas fir and silver fir do just grow more over time because they are conifers. Just have higher levels of growth compared to beech. These red lines are the years that there was drought, and this line is the late frost year, so where in May it was a cold period, and that quite impeded growth because it's an important month for ring formation. So that's actually the most cohesive reaction we could see. In 2003, more or less all species were impacted, and 2018 the most impact was on Douglas fir and silver fir, and beech actually unexpectedly didn't have that big of a reaction. It actually grew a bit. Here you can see beech again, but split into beech trees in different neighborhoods. So pure beech in light blue, beech with silver fir in purple, and in orange is beech with Douglas fir. Their chronology is quite similar. We can find significant difference. And here this growth in 2018, despite the drought, is possibly due to more spring precipitation. So beech might have had more access to water until the subsequent drought. And also beech is kind of known for sometimes having lagged growth reactions. So it actually only reacts maybe here in the year afterwards. We also modeled growth over time, accounting for size differences in beech. And here in yellow and purple are beech in mixtures, and they actually grew were more productive in their growth over time than beech in a pure stand. So that's actually something positive we can get from these mixtures. Here again, we just compared drought versus normal year. So this is a species comparison, so just each individual tree. And beech was higher during drought significantly, which is not surprising looking at the chronology we just saw, and the conifers kind of decreased. When we averaged the growth between the 2 trees on each stand, we see that there's no significant difference in pure beech, but also in beech and Douglas fir, there's no significant difference between normal and drought conditions. So this could indicate that this combination might be a bit more stable than, for example, beech with silver fir. So in summary, we can say that introducing drought-tolerant species like Douglas fir and silver fir into mixed forest it might be a supporting climate change adaptation. Effects of Douglas fir on native biodiversity are mostly non-significant, although further study is needed. And our retrospective growth analysis did reveal effects of drought, mostly on conifer species, but they were able to recover again, and on late frost on all species. So, and over time, beech mixtures actually grew more than beech in pure stands. So, forest admixtures, especially maybe with Douglas fir, to create this kind of more stability in growth, are beneficial, even though sometimes the effects might be unclear. But even so, if we have mixed forests, we have this effect of having more biodiversity and also being able to have these complementary effects between species. And the implementation of this obviously depends on the management goals and site requirements that you might have. More studies needed, as always, and next we will investigate the specific structure of their trees. So here you can just see some examples of point clouds of these trees that I sampled, so we can look at the different structural metrics and see if that had an effect on their growth performance, and also looking at the experienced drought stress through a wood stable isotope analysis, which could be an indicator of experienced drought stress along with just the growth analysis. So thanks for your attention, and any questions I'm happy to answer.